All right, so the coolest thing about Ladybug, I think, is that everything can really, or at least most of the base level analysis that you're going to have to do, can be contained in just a couple of components, a couple of nodes. Um, and the most important one right now, at least, is if you go under Ladybug and you go to not download, it is import EPW. Yeah. So if you go into Ladybug and you go to import EPW, it looks massive, like absolutely massive. Um, but the best part about that is that you basically have every bit of information about your location that you're going to need to generate a full set of analysis documents. You have the latitude, which is pretty simple. It's just going to come out as a number. Location, I don't know how that processes, but probably the one that you're most familiar with right now is dry bulb temperature. Right? It can simply be put as the temperature throughout the day, right, at any point in the year. And we'll talk about how do you isolate certain information in the diagram. But what we're going to do now is connect the EPW file so that information flows through it. Is this asking for a path? An EPW file path as a string. Yeah. So basically, I think we can just copy and paste this one down. This is a little different than I'm used to doing it, but if we take Fullerton and we plug it in, does it work? It works. So now you can put a panel, and I'm going to be using a lot of panels, guys, a lot of panels. If you put a panel on dry bulb temperature, what you'll see is a list of information. Okay, so the first one is, I'm not sure. The second one is the location. The second one, or the third one is what information is this, right? So this is basically just giving you title and information about the list. But once you get down to item index 7, it starts with these numbers. Okay, so the numbers are important to note because that is your dry bulb temperature. It's measured in Celsius though. So yeah, yeah, right. I know, it sucks. Get used to it, guys. The rest of the world doesn't work like we do.
We're America, though.
All right. So that's your dry bulb temperature. You can delete that. We're going to use it in just a second. But that's probably the coolest thing is that it takes that information for you, and it's a giant file. You saw all those when we had the mistake with Chino. You saw all that crazy coding and stuff, right? That converts it into this, basically. So then we have the other really cool one is the 3D grapher. And you'll see that this is probably the most simple analysis tool you could ever imagine. So I push this aside because the graph is going to pop up in Rhino. You should probably do the same. When I go to Ladybug and I go to visualize weather, so panel 2, visualize weather. And we're staying at the top now, right? We're not getting too deep into these other components, but Ladybug 3D chart. Ladybug 3D chart is built in such a way that you take these two pretty much go hand in hand. You're going to use them a lot together, where you take the information that you see listed here, right? Wind speed, dry bulb temperature, radiation, all that stuff, sky cover. You take that information and you plug it all into the input data. And that's at the top. It's easy to see. The rest of it is, the base point is where you're going to locate it in the Rhino model. That's simple enough. X scale, Y scale, Z scale is going to determine, basically the proportions of it. What size is it? Y count, 24 hours of the day. We'll talk about that later. Legend par, we'll talk about it later too. And condition statement. But bake it is different settings for how do you actually push this information out into Rhino. And then furthermore, you can actually take this information and break it down into geometry even further and then process it into other things. I have yet to find a use for that really besides graphically showing it in different cool ways, which we'll also do later. Okay, so now what does a graph actually look like? Let's take the dry bulb temperature and plug it into the input data. You should see at your origin a big blue thing show up. So just zoom out and you'll see what it really is. It really is this. Yeah, no, it came in pretty massive. But if you're unfamiliar with this type of graph, I'll familiarize you with it. So if you go all the way back down to your origin in the bottom left here, what you see is 12 a.m., which is midnight, and then 6 a.m. in the morning, and then noon, and then 6 p.m., and then 12 a.m. again. So as you move vertically across the graph, right, those are the hours in the day. And then as you move horizontally across the graph, those are your days in the month, essentially. So I don't know how they break it down. Maybe they do every other day, because this only looks like 15 of them. Well, no, that looks like 30-ish. So basically, each one of these rows is going to be a day. So on that hour, on that day, each of these blocks is measuring a temperature. So now let's go all the way to the right where they give us the index. And so basically, at the very end of the year, very early in the morning, we have something like a 4 degrees Celsius hour of the day at this particular time, which I guess is 5 a.m., which is pretty close to New Year's, I guess. Okay, so do you understand how that chart works? Okay, so now let's do something else that's pretty cool. Let's go into perspective. All right, that's pretty cool, right? So this information is not just two-dimensional information. Does it really give us a lot to look at it three-dimensionally? Maybe, maybe not. I don't know. It's up to you. We'll talk about how you present information later on in the semester mostly. But what we're going to focus on right now is just kind of getting raw data. So we're going to actually try to process this graph as something that's two-dimensional. So I'm challenging you guys now to kind of look ahead and start making inferences based on the information you have. How do we take a three-dimensional chart and make it two-dimensional? That's actually a pretty good thought, make 2D. I suppose you could use that workflow, but this tool already has a feature built into it that will convert it to a two-dimensional chart. What do you think that is, based on the information you see here? And I'll give you a hint. I'll zoom us into it right here. Sure. Any ideas? Nope, not bake it, not graph mesh. I'll walk you there. Okay, so, I mean, if you think about this in terms of its physical properties, right? The information that's embedded into this graph has to be using three different axes, X, Y, and because it's 3D, it has to use Z. So what do we do to make it a two-dimensional graph? Well, it's really as simple as taking the Z scale and reducing it to a value of 0. And we can do that by going up to params and panel. I make it really small here and 0. Did I go over last week strings and integers using panels? If you accidentally hit enter? I did? Okay. All right, yeah, so don't hit enter. Plug that into Z-scale. And it converts it to now a two-dimensional graph. Okay. Yes. Question. All right. So I have another thought about this, and you guys, those of you who are in the design class, are already thinking about presenting this information. The format that this information comes in is not necessarily very palatable, right? If I look at it in top view, it's big, right? It's very, very wide. Can I put that very cleanly onto a sheet of paper?
No.
In some cases, maybe. You could scale it, but how am I going to scale it?
X scale.
Right, X scale or Y scale, right? Very simple. So the problem for me is that it's too long. So if I want to make it basically half as long, then I copy and paste this, and I can go to the X scale and make this a 0.5. And then it shrinks all the information horizontally.
So is one full size?
What's that?
What's full size?
Full size would be 1, yeah. Huh?
Or just delete the panel?
Delete the panel?
The input.
No, well, you could just override it. Double click it, put in 1 if you want. Oh, or yeah, sorry. Or you could delete, yeah, because the default value is 1. Okay, so your first graph is already created. How difficult was that?
Pretty easy.
Pretty easy, right? Any questions? Okay,
So we can
stop here.